Hi, Algebra students. Here are the notes for section 8.2 on graphing quadratics in vertex form. Okay, so the goal of our lesson today is going to be to graph quadratics that are written in the form that you see right here, okay? Remember, we've been working on standard form, but in vertex form, it makes it super easy to see where the vertex is, okay? So by looking at the equation, we can see that our vertex is going to be at H, comma, K. So what you need to remember is up here in the formula, there's a subtraction sign in front of H. So if the subtraction sign is in front of H is positive. If there's an addition sign in front of H, then the value of H is negative. Okay, and you might also remember, just kind of leading into the second part of this lesson, that H and K also tell our vertical and horizontal shifts. So H is what represents our horizontal shift. And K represents our vertical shifts. Okay, so the easy part about this is you don't have to do any work to find the vertex. You just have to identify it from the form of the equation. And then if you remember, when we're graphing a parabola, so like if this is your graph here, if this is your vertex, the axis of symmetry is the equation that is the same as the value of H in your vertex, okay? So it's the form of x equals H, okay? The thing that you do have to do a little work for on this one is to find your y-intercept. So it is not always the value of K, especially if there's a shift in your equation. So you have to make sure that you do double check it. So just remember the y-intercept is found when it's the point at which x equals 0. Actually, I'm going to rewrite this and just say, oops, let's rewrite this. And let's just say substitute x equals 0 and solve for y, because that makes more sense. Okay, so we'll fix that. Okay, and you'll see all of this down below when we do some examples together. You'll see how all of this works. All right, so let's look at the first set of examples. It says, for each equation, provide the indicated information. So here, remember, we're just looking at my value of A is 2, and really this is just helping me get a visual of what my graph is going to look like. So if A is 2, I know that because that's a positive number, my graph is going to open up. Okay, the vertex comes from the value of H and K, which in this case is 3, 7. Okay, so remember that 3 stays positive and 7 stays positive, and then the axis of symmetry just comes from the value of x. So it's always an x equals equation. Okay, one other thing to really focus on in this equation that we're going to talk about is this value of A right here. That is going to cause our graph to stretch. So eventually we'll talk about that. So it is a stretch of the parent function. We'll come back to that in a little bit. All right, in number 2, the value of A is -1. So therefore, this is a negative value. Our graph is going to open down. And remember, we can also call that a reflection of the parent function. My vertex is at -4, 0, because remember here I'm technically adding 0 for K. So it's at -4, 0. And again, the value of H is the opposite of what you see inside of the parentheses. Okay, my axis of symmetry is just that value of H. X equals -4. Number 5, the value of A is 1/2. This is a positive value, so my graph is going to open up. And you might also be recognizing that this graph is in standard form. It's not really in vertex form. It's just a standard form function. So the vertex for this one is at 0, -5. The axis of symmetry is also at, I'm sorry, that is not a point. I was thinking of my y-intercept. That is not what we're looking for there. My axis of symmetry is y equals 0. And it's not y equals 0, it is x equals 0. Sorry about that. Okay, I was thinking about where we got the value of y. So remember, in a standard form function, if we know the vertex is 0, so remember, to find the vertex in a standard form function, you substitute 0. No, I'm sorry about that. It's negative b over 2a. Okay, so our b, there is no b value in here, so b would be 0. 0 divided by 2 times a half is just 0. So that's how I know that my x value of my vertex is 0. And then when I plug in 0 in place of x and solve for y, I get negative 5. Okay, so negative b over 2a is negative 0 over 2 times 1/2, which is just 0. All right, sorry about that. Let's keep moving. All right, this time it says, find the y-intercept. So remember, we said the y-intercept is the value when x equals 0. So set x equal to 0 and solve for y. So in the first one, I'm going to do negative 1/3 times 0 minus 3 squared. Okay, and just, again, this is all mental math, just order of operations. You might want to do a little scratch work here. 0 minus 3 is negative 3. Negative 3 squared is 9. So we're doing 1/3 of 9, which is 3, and that would be negative. And then if I write that as an ordered pair, my y-intercept is at 0, negative 3. For number 5, y is equal to 3 times 0 minus 2 squared minus 1. So inside my parentheses, 0 minus 2 is negative 2. Negative 2 squared is 4. 4 times 3 is 12, and 12 minus 1 is 11. So y is equal to 11, and so I would write my y-intercept as 0, 11. Okay, and lastly, number 6, once again, this is a standard form function. Okay, and remember, in a standard form function, the value of the y-intercept is the point at which, or sorry, not the point, just the value of c in the function. So it is this value right here. So no work needed on this one. So I would say my y-intercept is at 0, 4, although if you forgot that and you plugged in 0 in place of x, 0 squared is still 0 plus 4 is 4. So you can still do it either way. All right, let's look at the next example. So you have the picture of a graph here. It says, which of the following could be the equation of the parabola, and justify your answer. So some important things to notice about this parabola that you see in the picture is that it opens up. So the value of A must be positive. Okay, and I'm going to identify my vertex here. I can see in this graph my vertex is at 2, 1. Okay, so over here, using good process of elimination, if A has to be positive, I know that D is not an option. So I'm going to get rid of that right away. And then using what we learned earlier, my vertex is the value of h, k. I'm just going to calculate my vertex. So for choice A, my vertex would be at -2, 1. So that's clearly not the answer. For B, it looks like my vertex would be at +2, 1. So it looks like this is the answer, but I am going to double check C. So for example, C, my vertex would be at -2, -1. So that is definitely not the answer. So it looks like B is the best answer there. All right, let's keep going. And now we're going to put it all together and we're going to graph this. And please notice it says graph without using a graphing calculator. So just by using all that information we just learned, we are going to graph these quadratic functions in vertex form. So for number 1, I can see that the vertex, or the value of h, sorry, is at -2. Remember, it's the opposite of this value right here, and k is -3. Okay, that means my vertex, I'm just going to skip ahead, is at -2, -3. Okay, and this tells me that my graph is moving 2 units to the left and 3 units down. Okay, my axis of symmetry, again, is that value of h, so it's just x equals -2. The value of a is 1, so it's positive, meaning my graph is going to open up. And my y-intercept, this is where I need to do a little bit of scratch work here to find my y-intercept. Y is going to equal 0 plus 2. I don't know why I put a comma there. Hold on, let me fix that. It's just 0 plus 2 squared minus 3. Okay, 2 squared is 4, minus 3 is 1. So there's that. Okay, I generally put in my parent, this is my parent function here, just so you can kind of see what that's going to look like. Whoops, that actually goes there. So it's 0, 0, 1, 1, 2, 4. This is the parent function, and then we're going to graph the new function so that you can see. So the vertex of the new function is at -2, -3. That's this point here. The y-intercept is at 0, 1. So remember, I'm going to draw my axis of symmetry in there so that I can see where to reflect that point across the y-axis. And I'm going to draw that graph in. Okay. We can see that the domain is all reals. Y is going to be greater than or equal to -3, which is always the y value of the vertex. I can see that that graph is the same shape as the parent function. It just shifted 2 units left and 3 units down. All right. Number 2, the value of h is 1. Remember, there's nothing there, so k is 0. This one is shifting 1 unit right. Okay, it's not moving up or down. The vertex is at 1, 0. The axis of symmetry is x equals 1. The value of a in this graph is 2. So it's positive, and it's going to open up. The y-intercept is going to be 2 times 0 minus 1 squared. 0 minus 1 is -1. -1 squared is 1 times 2 is 2. All right, let's get a graph in here. And again, I'm going to start by putting in the parent function so you can see that. Here is the parent function. Okay, and then my new graph is going to have a vertex at 1, 0. So you can see that shift just 1 unit to the right, and a y-intercept at 0, 2. Okay. Okay, now we can see that our graph shifted 1 unit to the right. I'm going to give the domain, which is all reals. The range is y is greater than or equal to 0. What you might also notice is this graph is narrower than the parent function, okay? We call that a stretch by a factor of 2, okay? And that factor of 2 comes from the value of a. So it's 2 times bigger, or it stretches by a factor of 2, okay? So in other words, all the values are just being multiplied by 2. Okay, number 3 is actually a standard form function. The value of h in this one is 0, okay? There's no shifts horizontally, but there is a vertical shift. It's moving 1 unit down. Okay, the vertex is at 0, -1. The axis of symmetry is just x equals 0. A is -1. So therefore, that is negative. It is going to open down. And remember, we can also call that a reflection. Okay, the y-intercept for this one, when you substitute 0 in place of x, or again, it's just the value of c in the function because it's a standard form function. So it's 0, -1. Okay, and I should have put parentheses there as well. All right, so let's go ahead and start our graph. I'm going to put in the parent function here. And then the first thing I want you to notice is for this one, because it's in the form of ax squared plus c, is we don't have a middle term, so I only have the vertex and the y-intercept are the same. I only have that 1 point right here. So remember, when that happens, you just have to make a little table of values. You can choose any value of x that you want and plug it in and solve for y. So I'm going to choose 2. So in this function, -2 squared is -4, -1 is -5. So this would give me, now I have another value I can put in. So it's 2, -5 here and here, reflected across. And there's my graph. Okay, domain is all reals. This time y is less than or equal to -1. Okay, so it is a reflection of the parent function that shifted 1 unit down. All right, great job, gang. Let us know if you have any questions.